So we're going to discuss the fundamental type char. Char is going to let us do a lot of text processing. And char is the constituent in a string. Later we're going to understand how strings are just series of char. Actually, when we learn more about that, we'll see that a string is basically an array of char with a sentinel character at the end, which is basically a 0. So char is a fundamental data type, and a literal or constant char includes things like the lowercase letters. They're represented in your code as single quote x single quote, but also you could have a digit like 7, and it would be represented again, unlike it wouldn't be 7, because if 7 was without the quotes, then it would be the literal or constant int. And then, for example, there are also, and we've already used them, non-printing characters that don't show up directly on the screen but do something. And the most common one is \n, which tells you to advance to a new line. Now, you don't have to memorize this, but in most texts or online, you can find the values of the standard 0 to 127, so it's actually a table of 128 characters that can be printed, or the non-printing characters that will do some action on your computer system. And among those characters are, for example, the uppercase. And what's nice about the uppercase, if you remember, capital A is an integer value 65, then they actually appear in the ASCII table adjacent to each other, and capital B is 66 and capital C is 67, and so on until you reach capital C, which is 90. And similarly with the lowercase, though they're in a different place in the table. So a lowercase a is 97, and then it sequences all the way to lowercase z, which is 122. This is a bit confusing. Digits, when you use them as char, have a value. So the digit 0 as a character is actually integer value 48, and it is also a sequence from 0 to 9. So you have all the decimal digits available for purposes of using them as char or internally in a string, and they range from the integer value 48 to 57. And then there are others, all the other characters you find on the keyboard, and these are punctuation characters and operator characters and special characters like $, and they're all available in the ASCII table, and they all have a particular integer value, except unless you're a memorization freak, you're going to have to look them up. But of course you can quote them, and then they will indeed also have this internal integer value. And one of the things about this is you can store these in a byte. So you can use 8 bits and store the any of the ASCII values. Now, non-printing characters are very important as well because they promote actions on your computer system. \n, see, you can't have n because that would be printed as n, but \n sort of escapes it. So the idea is \n is a special non-printing character, and indeed when you put it in a printf, integer value is 10, but what it does is advances to the next line on the screen. \a is also a non-printing character, and if its value is 7, And if you were to use it inside a program, it would, on your system, ring a bell or make a sound. So that's the character set you can use. And now let's show a simple program for how that may be used. So I wrote this program to show how it would be used in a very simple way, just show how the characters, when printed as a %C, see here, %C is in that format string, that's going to print out as a character. Notice the character is declared, the variable C is a character variable, and we're going to assign it, again, quote, single quote, a single quote. And now we're going to print it in two different ways. In the first way, we'll print it as a %D, so it should show up as an integer. In the second print, it should show up as a character. And then we're going to do the following to show you that these values, the ABCs, are going to be sequential. So we have 3 characters to print, and they're going to be C, C+1, and C+2. So those are integer expressions, but they're interpreted as a character. So in effect, the ASCII table gets used to show what gets printed. And here, if you run this on your local system, you should hear something. You should hear 3 distinct noises or bells. And here you have this \A, which I talked about as a non-printing character. Of course, there's a non-printing character here too, and that's in the string, and that's interpreted by printf. So printf knows how to interpret that. And if I had put that over here, if I had made that a character to be printed using the %C, then what I see is nothing but an advance of the screen. So let's run this. I already compiled it. And you see its output. The character C has an ASCII value 97. As I said in the beginning of the lecture, that's the character A. So when I print it as an integer, it printed as 97. I printed it as a character, it prints as an A. The 3 consecutive characters that got printed are ABC, just as we expect. The 3 bell rings, nothing got printed, but I heard them locally. I don't know if the microphone picked them up, but there was a bing, bing, bing. That were, in fact, the printing of those 3, quote, non-printing characters.